I will invite the next presenter, who is Professor Arne Winther. The floor is yours, and then we shall have comments after him, and then you can ask whatever you want.
Okay, thanks a lot. Can you hear me okay? Okay, thank you for the two last presentations. It's encouraging to see that we have facilities who can take care of our waste, and the presentation made by my colleagues from Chinese National Oil Operating Company, Tower, and Total is a very good complement to the presentation I'm going to give. And I'm also sure that we will do the best we can to give our friend from Ghana as little waste as possible. That's the objective of our waste management program. But still, there will be a lot of work. But we do our best to reduce it. So, when it was mentioned, and I'm going to tell about the experience from Norway, and that's just limited to the condition to operate. If you don't fulfill those conditions, the oil company or the service company is not allowed to operate. We have different solutions. As you said, we are doing the work offshore, and this is on land, so I'm going to bring some experience we've had on land operations. To be able to do that, I will explain a little bit about the drilling activity. That's going to bring us from the drilling location, how we make that one, and how we make the infrastructure to be able to run the operation, how we bring in the rig, because the rig move itself is quite a substantial activity with a heavy load on the roads, and it's traffic. Then quickly through the drilling of the well, that was the objective, and some of the waste we get when we drill the well, and then after we have done the job, we have to clean up so that the place is reinstated. And then we go through the main part of what we're going to discuss, that's the aspects and the impacts of the drilling activities. And last and not kind of mitigations, and then I'd like to mention the three main ones which we'll come back to. So, infrastructure. Before we're able to reach a location, we have to make infrastructure. To the left, we have access roads. This is from the desert in Sahara. Okay, you need to make similar roads here, and the challenges are different, but a lot is familiar. We may have to make roads. In the desert, water is scarce, and here we have a photo of some local persons from in Amenas, and we gave them job, and they had a 2 weeks job to get water. Water is scarce in the desert, and in this way we are forced to learn how to treat water as a finite resource. Then the location is ready, and we can go for the rig move. This is just to give an impression of what is involved with the rig move. A lot of heavy trucks, many trucks, and if it is passing through villages, this is a risk. And it was also noise and dust, and it should be considered when we move a rig around. The loads, we talk about weights of about 100 ton. Number of trucks, 100 to 140. Once the drilling location is ready, we have the drilling rig set up, and if I can make, okay, we got the drilling rig, the tank farm, power generation, pipe rack where we have the steel pipe we use when we drill the well, and that is then put somewhere in the landscape. So then we're ready to drill. That starts with setting a conductor pipe from the surface down to a certain depth where we have competent soil. And with the conductor in place and cemented, we start drilling. So we drill with a drill bit inside the conductor down to a certain depth where we have to set a new steel pipe or a casing inside the valve. And that's the next, and the second then is a steel pipe set inside the casing. Sorry. This one is then called a surface casing, and that one could go through the aquifer. And that's the first challenge when we drill a well. We cannot damage the aquifer because that's the water we live on, that's the water we drink. So, how do we solve that? We set the casing through the aquifer, that's indicated in yellow. We set the casing, the steel pipe through, which isolates the well from the aquifer. And then we cement it, so we have a good impermeable layer between the hole we have just drilled and the casing, so that nothing can come from the well into the aquifer. And also from the top we have to isolate. So that is an important step before we continue the well. The aquifer must be isolated. Then we continue, and we are, as you see, approaching the reservoir, setting the last casing, which is the production casing, and finally the liner through the reservoir. This takes us from 2 weeks to 4 weeks to complete. And now we have produced some drill cuttings, which was mentioned before. Typical well 2,400 meter, typical hole sizes, and 650 cubic meter of drill cuttings. These cuttings is polluted with toxic liquid. That could be oil-based liquid, or it could be water-based liquid. Water-based is toxic in the mean of when we use polymer in the drill fluid. The polymer is coated with with biocides, which then will pollute the water. We will have runoff, or we could have water going to the rivers or to the field, and we start to introduce toxins. We came to the point where we see that the drilling of the well is producing some considerable amount of cuttings. So 650 ton times how many wells we were going to drill will then approximate the number which was presented by Ronaldo earlier this morning. It's a large amount of toxic waste. So we have drilled a well, and next step is to put a well on production. Then we put a pipe inside the casings we have installed, install a set of valves to control the flow, and we do the cleanup and testing of the well. And that looks like that. Can you imagine this in Murchison Park? This is how it is often done, but it doesn't have to be done like this. This is actually from a cleanup done in Saudi. Okay, so let's go through then the main part, which are, it's a bit hard to see this on the screen, but it's the activity. The activity has certain aspects. Like the cleanup, the aspect of the cleanup was smoke, noise, and pollution. So then we look at the next, which is then aspect mitigation. How do we reduce the aspect of what we do? The aspect will have an impact. It could have an impact on the environment, it could have an impact on the local society, or both. So how do we reduce the impact? So these are the steps we are going to briefly discuss. The new ISO 14000, which Annik is going to talk about, is going to introduce this material flow diagram. It's input, we have activity, and this activity is going to make a product, and it also has some outputs, which are emissions and pollution to the surface. So this is then a proposed way to represent the drilling activity from the new ISO 14001 material flow diagram. So to drill a well, what goes into this activity? Okay, the drilling rig and the equipment, we need energy, we need chemicals, we need location and infrastructure. The output is probably a well, if you do the things right. And what are the outputs? That's well fluid and drill cuttings waste, we talked about that, some 650 ton per well. We have solid waste, that's from our surface activities. We have wastewater, we get that from human waste, we get it from the kitchen, the shower. And we have subsurface fluid losses, which then was mentioned, like how we protect the aquifer. We also have emissions, and okay, we could say noise is an emission as well, but it's an important factor we should take into consideration. We have experienced noise levels of about 120 decibel when we clean up gas wells in Algeria. 120 decibel is what you get when you stand behind the jumbo jet taking off from Entebbe. So how do we reduce the aspect? By rig design is one way, because the best way to do it is to do this in the design phase. We should design the rigs to have minimal aspect. This could be done on old rigs, but definitely if you do that, when you start on the drawing board with a new rig, we get the results we want. I will mention the rig hoisting and rotary system. Old technology, DC, it has a high demand on energy, and it is heavy, and it is really not the future. That AC current, and we can control it in a much better way, and also much more energy efficient way than we do on the old American inheritance, which is then the DC equipment. Power generation. Here we have new legislations about allowable emissions from diesel engines. These are international standards and should be adhered to. It's not easy, because it also put a maximum sulfur content into the diesel. Now it is less than 1%. And with this sulfur content, most old engines will break down. So it's not done overnight, but we should know exactly where we're going, and we should also set up a target date where we should be there, where we are in compliance with the international standard. Chemical storage, other example. It was mentioned before, we should have chemical storage in such a way that it doesn't pollute. Bonding. If you have a leak in a sack, in a tank, whatever, you should have bonding. Diesel tanks. Imagine if you have a break of a 30,000 liter diesel tank. We could have double skin diesel tanks, which is the most common way. If you don't have that, you can make bonding, so that if you have a leak, it will be collected. Management. It starts with good management. You have to be a proactive management. We're very good at making reports after things have gone wrong. That's late. So, use of standard. It should be a condition to operate that the company working in any country should have an ISO 14001 certification. Then the need for double standard is gone. Then we have the same standard regardless where we operate, and that is the way forward. We cannot accept double standards. API is another standard. It sets requirements to the equipment we use. I heard a story here from our friend from Ghana. He said, when we have drilling fluid, he has to test it for heavy metals. Yes, you have to, because API define a standard for some of the chemicals we use, maximum lead content. It's not allowed in the US, it's not allowed in Europe. Is it allowed here? I don't know, but the gentleman had to test it. Company standard. What is the company standard for health, safety and environment? You should have the one and the same standard here and in the country it comes from. Rig maintenance. That's the key. When does rig maintenance start? It starts when we build a rig. Then we build in all the maintenance procedures from the vendors, from all the equipment. So the day the rig starts, the maintenance system is up and running. This is a main challenge because they think a new rig doesn't need maintenance. How wrong can we be? And other key, crew competency. We have to have a professional crew. That's also for safety, because the work we do is safety critical. We have to train the crews. They need to meet qualifications. The driller and the man operating the rig need to have international certificates, for instance, on well control. If something happens, if you have a blowout in Lake Albert, 90 days later, this blowout could be entering the Mediterranean via the Nile. It's not much to be proud of. Okay, let's look at some of the big ones. Sewage treatment. There are about 100, 120, 30 people on the drilling location or at the camps. Nature makes us produce human waste. That has to be treated. So, that is all collected, and this is the schematic and how it is done. Is just to show it goes from the cabins, the toilets, into a lift station. From the lift station it goes to something we call a SAF unit. It's a submerged aerated filter. There we add the bacteria, which is consuming the human waste, and we add oxygen. This speeds up the process, which in natural terms will take a month. Here it takes less than, that's half a day to 1 day. Then it's a recycling tank. These two tanks could be one, but it's recycling. And here we also produce sludge. Get back to that. And then we have overflow, and we have a chlorination tank. Chlorination kills the bacteria. And then it has a certain standard, and we have the effluent water which we are allowed to dispose. There are regulations on that from national, or the World Bank is also giving regulations which we then could adhere to if there are not any clear regulations in the country we operate. From the recirculation tank we have a sludge. That one also needs to be treated, and the end product of the sludge could either then go together with biological waste and become fertilizer, or we could bring it to our friend from Ghana for the incineration. Okay, once we are finished, a bit hard to see, but I can just mention what we do. We have a drilling location cleanup, and the scope on the location, all debris, scrap, metal, wood, chemicals, whatever is there, has to be taken away. The area shall be spotless. Drilling waste, we could have evaporation for the water-based fluid as long as we have no toxic chemicals in the drill fluids. And here is how important is it to select the chemicals, because we can substitute poisonous chemicals with non-toxic chemicals. And the water pit, if it is lined, then we need them to take away the plastic liner and backfill. Because if you don't do that, people, children, anyone can slide into that tank on the plastic and they would never be able to get up again unless somebody see them and help them out. Okay, we have domestic waste. The domestic waste pit, that will need to be backfilled. The flare pit need to be backfilled, and so on. Infrastructure, water valve. Maybe somebody needs the water. It could be handed over to local community, or it need to be suspended. On the well pad, we have a concrete slab where we put the rig. If we select to use the concrete slab, it could be left in situ for future operations. Access road, okay, somebody needs it, we can leave it. If it's not required, they should then be decommissioned and the area reinstated. So waste management is how we reduce the amount of cuttings that sent to the waste management or the waste handling companies. We reduce the amount of chemicals we use. That's technology. We have efficient processes which can get the same effect with less amount of chemicals. Then reuse. We will be able to reuse chemicals by, for instance, the drilling fluid. If we have good solids control equipment, we can reduce the drilling fluid instead of disposing it. We changed out our shale shakers, excuse me, that's the cleaning mechanism for the drill fluid. We changed them out where we were, and it paid back after 2.5 wells. So after every 2.5 wells, we got paid for those shale shakers with less mud consumptions. Not recycling. We could use the chemicals again, over and over again, if you have a plan. So this is the waste minimization, and then the rest then has to be sent to the waste management companies. Segregation, this is just illustration how we could manage the waste produced on a drill location. We have all kind of waste like electric cable, food, steel, cardboard, paper, tires, mixed plastic, wood, and then we could incinerate, we could put it on a landfill. That's not the way we should do it. We should reduce those two on the bottom and go for reuse or recycle. Instead of burning wood, it could be recycled. Instead of putting glass on a landfill, it could be recycled. Because we get paid for glass. It could go into factories and be reused either as glass or other products made on glass material. So these two boxes on the bottom will be, the size of these will be reduced if you have a proper waste management plan. Some waste is hazardous, like medical waste and some biological waste, and that need to be incinerated at high temperature so the toxins are killed. And some, like heavy metals, also need to be specially treated. Let's look at the third one. We are now been talking about the cuttings. No, the second one. We've been talking about the waste generation, and now we get to the drill fluid. We use the same ISO illustration on the flow diagram. We introduce chemicals, energy, water or base oil, and then we get drilling fluid, and I also put on a drill valve, because we cannot reduce on the quality of the drill fluid, because then the drill valve will be very difficult to drill, and it will actually pollute more than if you don't use the right kind of drilling fluid. Same outputs, fumes, dust, and noise. And here we have waste drill fluid, drill cuttings, chemical spills, and soil contamination. So how do we address this? How do we reduce those aspects? Water-based, we say runoff to the surface. We have pollution to the subsurface, and also similar for the oil-based. Similar aspect, but we see we have completely different solutions for these two. We mentioned on the drill cuttings handling. We could leave it in the waste pit. It will, if you have a dry climate, it will evaporate, and it could be backfilled and covered. We could have re-injection. We could slurrify the cuttings and re-inject it into a suitable formation. Stabilization was mentioned. Land spreading combined with bacterial degradation was mentioned, and incineration was also mentioned. There is another technology as well I would like to mention, that's the thermal cuttings treatment, where we treat oil-based cuttings. Here is an illustration on how this plant could be. We have the cuttings or the sludge or the slopes here, 2 tanks, and we have then facilities to, there's a front loader, and here we have trucks, and this is the actual facility. I'll show you more of that later. But the output, you see, we could have 2 to 6.5 ton per hour capacity on such a system, and the recovered oil 0.4 to 0.7 ton per hour, recovered water about the same amount, 0.4 to 0.6, and non-condensable gases about 3 cubic meter. And the quality of this output is you can't see it, but you have to trust me if I read it from here. It's oil on cuttings, less than 0.2%. What we have experienced on this is in the ballpark of 0.1%. 0.1% oil on cuttings, that's what we get out of it. And the flash point reduction, it's important for what we're going to reuse the oil for. It is reduced by about 5%. So, water in recovered oil, less than 1%. And oil in recovered water, less than 0.1%. The process is shown up here. We have a feeder, a pump, and it goes through a mill. This mill is high temperature, which it flash evaporates the drill cuttings. It's about 1500 degrees. And then the flash evaporated gases goes here into a cyclone, and from the cyclone we get the solids. The remaining solid go out together with the solids here, and we get the clean drill cuttings. Actually, this has then been transformed into a whitish powder. The evaporated gases will then condensate into oil. This is actually the recovered diesel. And water, less than 0.1% diesel on that. Yeah, we are running a bit out of time here, but okay, low pressure, and we can look at the drill fluid systems, how we can reduce the amount of material we have to treat. And that goes on the low pressure mud system. And it is designed to reduce the chemical consumption, as we mentioned, and to minimize the amount of drill fluid. lost in the solid controls process. If you have bad solids control equipment, we lose, and we can halve the mud consumption by having proper equipment here. We could look at the mud mixing system. How much chemicals do we need to get a certain parameter? By having high sharing capacity, we can reduce it by 20-30%. Mud cleaning equipment, same. We can recover, or we can reduce the mud consumption by, we have seen more than 50% by having proper equipment, and it pays back big time. Summary. We have been discussing briefly then the drilling related activities, how we set up the drill location, infrastructure, remove the drilling on the well and the well cleanup with the flaring of the oil. And we mentioned the aspect of this. Some photos didn't really require comments, but then we also mentioned how we could mitigate for the three big ones. That's drill fluid and cuttings handling. That's the sewage water treatment. And one important thing that if you do a thing like that, because this is the bacterial process, input is important. If you do the wrong input, like putting chlorides together with the wastewater from the kitchen, or have a lot of kitchen oil poured into the same system, it will not work. So this needs to be managed, it needs training, you have to know what you do. And then we talk about waste management. It's not only beneficial, but also create jobs. So that was quickly what I have in mind on this, telling a few words then about the drilling operations and how we are today. There are still a long way to go, but we have to start somewhere, and this was then what I wanted to share with you. Thank you.
Thank you, Prof. You can take your seat. I'll be hovering around with the mic, and then we shall have a couple of questions, as the standards will be set by my colleague Charles. After you've asked questions, then we shall give the presenters a chance to answer them. Still, let's keep our half-full glass, even when it is getting empty. Let's see it as getting filled later on. So I entertain the questions, and I'll have to go with the mic, and Chelsea, you can take up the podium.
Thank you. It would be indiscipline on my part to assume that, to try and make a summary of what the presenters have said. I am optimistic that you are listening in and taking notes where necessary. I know there have been 3 long presentations, taking a total of 1.5 hours. So to be able to pick up from where we started with Ronald, and then go to Mr. Kwaku and Professor, might be a long one. This is what we do. We pick about 4 questions or comments. They respond. If time allows, we pick another 4 or 5. They respond, and then we find a way to wind up the discussion. Let me request that you be as democratic as you can. So keep your question or comment as brief as possible to allow as many people to participate. Thank you. And tell us your name.